In this video, I will introduce to you how to construct truth tables for a given sentence of our logic. First, I will introduce to you what these truth tables are and why they matter. So here is a definition of a truth table. A truth table for a sentence phi indicates every possible valuation of truth values for the atomic sentences in phi, and for each such valuation, the truth table says what the corresponding truth value of the entire sentence is. So this is a mouthful, but as this video progresses, hopefully it will become clear what this is saying. But just in summary, what a truth table tells you is all the possible combinations of truth values that the atomic sentence letters in phi might have together. And for each of those possible assignments of truth values to the atomic sentences, it tells you what the overall truth value of phi is in each of those cases. So why care about truth tables? Since a truth table for a sentence will tell us every possible truth value it might have, we can easily tell, after having constructed one, whether the sentence is tautologous, contradictory, or contingent. So these notions of tautology, contradiction, or contingency, and related semantic notions we introduced previously a couple weeks ago. And in the lecture on Wednesday, in the next lecture, I will be giving all the rigorous definitions of these semantic notions in terms of our developed semantics. But just to foreshadow, for a sentence to be a tautology is for it to have truth in all possible rows of its truth table. That is, for a sentence to be a tautology is for every possible assignment of truth values to the atomic sentences in it results in an overall true statement. Similarly, or relatedly, for a sentence to be contradictory is for the entire sentence to be false on every possible assignment of truth values to the atomic sentences. And for a sentence to be contingent is for it to be true on some assignments and false on others. So we can also compare the truth tables of multiple sentences to tell whether there is entailment, equivalence, consistency or inconsistency, and contradictoriness. So, truth tables give us a procedure for determining which semantic properties or relations sentences have or stand in to each other. So, as I just mentioned, these semantic notions that we've already introduced at an intuitive level, so for instance, tautology, contradiction, contingency, entailment, equivalence, etc., all of these semantic notions will be defined rigorously in the next lecture. And then once we have the definitions of those notions, we will be able to use truth tables, which we will learn how to construct in this lecture. We will be able to use these truth tables to determine systematically whether a sentence has these properties or whether groups of sentences have these relations. So just to foreshadow, here's a very quick illustration of this before I discuss how to construct truth tables. So here we have a truth table that compares the three sentences, if P then Q, P, and Q. And what this truth table tells us for these three sentences is that we can tell from looking at this truth table that the argument with the first premise, if P then Q, and the second premise P, to the conclusion Q is a valid argument. And what that means, to foreshadow, is that what it means for this argument to be valid is for any valuation or any possible assignment of truth values to P and Q, any assignment that makes the premises true also makes the conclusion true. So what we do is we look, here we've constructed the truth table. So on the left-hand side, we have all the possible combinations of truth values for the atomic sentences P and Q. And then what we do is we look under the column for the main connective of each of the premises. So here the main connective is the conditional. And here, P is just simply the sentence letter itself, so we look at what's under P. And in every row in which both premise 1 and premise 2 are true, the conclusion is also true. And the only row in which both premises are true is the first row. So in the second row, the first premise is false. And in the bottom two rows, the second premise is false. But in the first row, we see here that the first premise is true and the second premise is true. And in this row as well, we can see that the conclusion is also true. So that's to say, whenever the premises are true, the conclusion is also true. So after having built this truth table for these sentences, we can tell by looking at it that this argument is valid. And this argument, hopefully you can tell, is simply an instance of modus ponens. So using the truth table here allows us to see systematically why it is that modus ponens is a valid argument. Okay, so before we're going to return to constructing truth tables to tell whether arguments are valid, say, or whether sentences are tautologies, contradictions, or contingent, and all of this fun stuff. But before we do that, in the rest of this lecture, I'm going to tell you a method for how to construct these kind of truth tables. So I'm going to give you a method for constructing a truth table for an arbitrary sentence phi, no matter how complex phi is. In the example we just saw, here we combined the truth tables for multiple sentences, and doing so is a simple extension of this method that I will now show you. So the first step 1. So you begin with your sentence phi, and this can be as complicated as you want. The first step is you determine the number of rows that will be in the truth table. And the number of rows is 2 to the power of n, where n is the number of atomic sentences in phi. Now, the second step is that the table will have n plus 1 main columns. It will have n columns for the atomic sentences in phi, and 1 for the truth values of phi itself. So these first two steps tell you how many rows and columns you will have, or more specifically, how many rows and how many main columns. But if phi is very complex, you might also have, as step 3 says, some quasi-columns. So if phi contains many different complex sentences, you're going to have an additional quasi-column for each complex sentence. So now, step 4, when you really start constructing it, what you do is you place the atomic sentence letters in the leftmost columns in alphabetical order from left to right. Then you place the entire sentence phi in the rightmost main column. Then what you do is, underneath the atomic sentence letters, which you've listed out in the leftmost columns from step 4, what you do is you write all the possible combinations of truth values for the atomic statements. And again, there will be 2 to the power of n of these. So there will be 1 for each row of the truth table. Now, the way in which you go about listing out all the possible combinations of truth values is what you can do is you can follow the following convention. So you start on the nth column. So you start on the last of the atomic sentences which you've listed, and you write down, going down this column, alternating between true and false until you fill it. Then you go to the n minus 1th sentence letter, and you don't alternate 1 by 1, you do 2 t's and 2 f's, and you alternate that pattern until the end. And if there's more and more atomic sentence letters to cover, you then, on the third last one, you do 4 t's and then 4 f's, and continue that pattern. And so you kind of double the amount of t's each time. And you do this until you get to the very first column, i.e. the first sentence letter that you've listed. So I'm going to work through some examples with you in a second of applying this method, okay? But I wanted to first give you the general abstract method before we work through some examples, okay? And so once you finish step 6, so once you've listed out all the possible combinations of truth values for all of the atomic sentences, what you do is you compute the truth values of phi in each row of the table. And what you do is you start from the inside out. So the first thing you do is you copy the truth values of the atomic sentences according to that row to the right-hand side where phi is listed. Then you work out computing the negations, conjunctions, etc., which make up the complex sentence phi. And then once you've filled out all of those, you'll be in a position to compute the value of the main connective. And once you've computed the value of the main connective of phi, you will be done the table. So in the next couple of weeks, and also for the midterm, being able to construct truth tables in order to assess whether sentences or groups of sentences have certain semantic properties, it'll be very important that you are able to do this, that you are able to construct truth tables. So this method might seem a bit intimidating if you haven't actually looked at truth tables or constructed them. But let me now, in the rest of this lecture, look at some examples and work through some examples with you. So first, I want you to look at this truth table I have for this very complex sentence. A, if and only if, B, and A. So you see there are 3 main columns. So the 3 main columns are the one for the atomic sentence letter A, the one for the atomic sentence letter B, and then one for the main connective, the biconditional. And then here are quasi-columns, which correspond to the sentence letters in the actual formula and the connectives which make up the subparts of the overall formula. So what we have done is we list on the left-hand side the 2 atomic sentence letters which make up the whole sentence A, if and only if B and A. And then we list all the possible combinations of truth values for A and B. So following the convention we gave for listing that, what we do is we start on with the second and last sentence letter, and we alternate between true and false. So TF, TF. And we know there's only going to be 4 rows because, as was given here, the number of rows is 2 to the power of n, where n is the number of atomic sentences. And there are only 2 atomic sentences, A and B. So A occurs twice, but that doesn't mean that there are 2 different A's, right? There's only one atomic sentence A which occurs in here. It just occurs multiple times. So we know since there's 2 atomic sentences, we know that there's 2 to the power of 2 rows, which is 4. So we start with the rightmost of the atomic sentences and we alternate 4 times between true and false. And then we move to the left and then we alternate by doing 2 trues and 2 falses. And by following that method, here we have managed to write out all the possible combinations of truth values that A and B can have. So they can both be true, they can both be false, or one can be false and the other true in 2 different ways. Okay, so that brings us to the end of step 6. And then the last step is you have to go through each row and compute the truth value of the entire sentence for each row. So for this row, you have to build up the entire truth value of the biconditional given the specification for the atomic sentences. So the first thing you do is you copy in the truth value for A and B and A from what they are here. And then you look at this subpart, the conjunction, and you see that B is true and A is true, and then given the meaning of a conjunction, given the truth table for a conjunction, which we gave in the last lecture, since B and A are both true, the entire conjunction is true. And then you compare the truth value of A with the truth value of this conjunction B and A, and you see they're both true. And then given the meaning of the biconditional, which was discussed in the previous video, the meaning of the conjunction was also from the previous video, not the previous lecture. But in any case, what you do is you see how A is true on this row, and B and A is also true. And so because A and B and A on this row have the same truth value, given the meaning of the biconditional, the entire biconditional gets the truth value true. So that's how we complete this row, given the specific truth values of the atomic sentence letters on this row, and then given the meanings of the connectives as were given in the previous lecture. So now we move to the next row, and we can see how this row, how all of the truth values on this side are filled out by looking at the specific truth values of the sentence letters, and then also looking at the meanings of the connectives. So here, the first thing we do is we copy and paste true for A and false for B underneath the occurrences of those letters on the right-hand side. So A gets true underneath it, B gets false underneath it, and A gets true underneath it. And then we look at, well, what is the truth value of B and A if B is false and A is true? Well, given the meaning of conjunction, the conjunction is actually false because conjunction requires that both conjuncts are true. So we fill in a false here, and then we wonder about the truth value of the entire biconditional. So we compare the truth value of A, which is true, but then the truth value of B and A, which is false. And then given the meaning of the biconditional, both parts have to have the same truth value, but they do not here, so we write false. So on this valuation, where A is true and B is false, the entire sentence is false. And we do a similar thing to fill out the other two rows. So here are some exercises which in the reading for today, at the end of the reading, there were I gave you many sentences which you could practice creating truth tables for yourself, and I highly recommend that you do so. And here are some more exercises, and I'm going to work through a couple of these in the remainder of this video so that you can help you get a sense of how to construct truth tables. So let me begin with the very first one. And what I'm going to do is I'm going to construct here using my fancy graphics tablet. I'm going to construct for you the truth table for this sentence. So the first thing we do is we figure out how many rows are there going to be. So there's only one atomic sentence here, N. It occurs 3 times, but there's just one atomic sentence, N. So that means that there is 2 to the power of 1 rows, which is just 2 rows. And in terms of columns, there's going to be a column for N. This might be very messy, but I'm going to try my best. So there's going to be a column for N. And then to the right of N, there will be the entire sentence, which is if N, then if N, then N. And underneath this connective here, this is the main connective. So underneath here is the main column. And then underneath the ends and this other conditional are quasi-columns. Okay, so now what we want to do is fill out all the possible evaluations. In this case, there's only 2 rows, there's only 2 possible evaluations. there's a case where n is true, and there's a case where n is false. Okay, so there's only two possible cases to consider because there's only one atomic sentence letter, so you only have to consider the case in which this n is true and the case in which n is false. And then for each of these cases, we're going to build up what the truth value of the entire sentence is. Okay, so the first thing we do is we simply copy and paste what the evaluation says n has underneath the occurrences of n for the sentence. And we can do the same thing for the second row. But now we have to build up for each row. Given our knowledge of how the connectives work, as was given in the previous video, in the first part of this lecture, we have to look at, given these meanings for n, what do we get for the connectives? So we start with this subformula, which is if n then n, and we're going to determine what its truth value is, given the truth values of n. And then once we've done that, we're going to look at the main connective. So we start with this subpart, if n then n. Now, if you recall the meaning of the conditional is true in all cases except where the first part is true and the second part is false. So actually, neither of these cases, neither of these rows, do you have the first part true and the second part false. So for both of these rows, this conditional part, if n then n, is true. Okay, now in order to determine what meaning the main connective gets, what we do is you compare this column here with the column for the subpart of the conditional that we just built. So these two things, these two columns, this one here and this one here, you have to compare their truth values given our knowledge of how the conditional works in order to fill out the main column here. So again, for the conditional, it will be true in all cases except where the antecedent is true and the consequent is false. And here we see that neither of these cases are cases in which that holds. So actually in both of these cases, the entire sentence is true. So we see in this main column for the main connective of the sentence, if n, that if n then n, no matter what truth value n gets, the entire sentence is true. And that's to say that this sentence here is a logical truthhood. It's a tautology. And we can tell that by constructing the truth table and then looking at the main column, the column under the main connective, to see what distribution of truth values it gets. And in this case, it only has t's. So that means that in any possible case, whether or not n is true or not, whether or not n is true, the entire sentence is itself true. So this entire sentence is true no matter what. Okay, so you should try constructing yourself the truth value for this statement. And it's very similar and it's pretty simple because there's only one atomic sentence as well. But now let me try constructing for you the truth table for this third sentence. If S then R and S and not R. So the first thing to note is that there are two atomic sentences in this formula. There is S and there is R. So we know that there will be 4 rows of our truth table. And we know for columns that there will be 3 main columns, one for S, one for R, and one for the entire formula, of which the main connective is this conjunction here in the middle. So let me switch to this other screen. Okay, so we have first column for S, second for R, and then to the right, we'll write out the entire sentence, which is if S then R and S and not R. So let me just switch back to confirm this. Okay, so that is right. So the first thing we do is we're going to complete each of the assignments of possible truth values to the combinations of atomic sentence letters. So following our method, the way we do this is we start with the right-hand one, and we alternate between true and false for the amount of rows. And again, we know the amount of rows will be 4 because the amount of rows is the number of atomic sentences, n, so it's 2 to the power of n, which is 4. So we alternate between true and false 4 times, and then we move to the left to the other sentence letter. And then here we alternate by doing two truths and 2 falsehoods. So now we know all the possible combinations of truth values for S and R. And so the rest of our job is filling out each row of the truth table for our actual sentence by relying on the specification of the truth values of the atomic sentence in that row and our knowledge of how each of these connectives works. So in this case, I'll go row by row. So the first thing we do is we put in what the truth values are for the atomic sentences, which we know just by looking at the left-hand side. And then we use our knowledge of how the connectives work to percolate this up till eventually we can fill in the column for the main connective. So the first thing we can do is note how negation flips the truth value of its negated sentence. So because in this case R is true, not R will be false. And now we look at this conjunction, and we recall that a conjunction requires that both conjuncts are true. So here it's important that we're comparing S and the entire truth value of not R. In this case, not R is false. So we look at the two truth values, true and false, and we realize that we need both of these to be true for the entire conjunction to be true. So we know that this conjunction is false. Now we look at this next part of the other conjunct of the main conjunction of our sentence, and we want to figure out what the truth value of the conditional is. And again, we remember that a conditional is only false when the antecedent is true and the consequent false, but here they're both true, so we know this is true. And then now we have enough, now we know the truth value of the two conjuncts that make up this. Okay, so again, we have to compare. So we have to compare these two columns, the one under the one under the conditional and the one under the conjunction. And we look at those two truth values and then apply our knowledge of conjunction. So here, this first one is true, the second one is false, so the entire formula is false in this case. Now we move on to the second row. So S is true in this case, but R is false on this row. So we just fill out that according to our valuation. And now for the negation, we flip the true to false. Now we see how actually both conjuncts are true. Not R is true and S is true, so this will be true. And here we actually have the case in which the conditional is false because S is true and R is false. So the conditional is false, and we compare false with true, and in order to get a true here, we need both of these to be true. So this is false. Again, so now we go to the third row. Now we just fill in the truth values under the S and R according to what this third row says. then we can do the negation simply, and here we see that both of them are false, so the conjunction here is false, but here the conditional is true. But again, we have that one of the conjuncts is false, so the entire sentence is false. Now our final row, which is a possibility where both atomic sentences are false. So we just put in falses for the atomic sentences, and then we apply our knowledge of the connectives again. So this will flip. So we compare true and false. So S is false, so the conjunction S and not R is also false. And then, but this conditional is true because it's not the case that S is true and R is false. In fact, S is false and R is false. And in that case, the entire conditional is true. But then we compare the conjunction. We have the one conjunct being true where the second one is false. So in this case, we have false. So now if we look at the column under the main connective of our formula, if S and R and S and not R, we see that in every possible case, for all evaluations, so for any possible combination of truth values of the atomic sentences, for all of those, the entire sentence is false. So what we know is that this sentence is a logical falsehood. This sentence is a contradiction. It's logically impossible to make this sentence true. No matter what the truthhoods of the simple sentences within it are, the entire sentence is false. So in every possible way things might be, this sentence is false, which means this is a contradiction. So here we have built the truth table, and then we can see the logical status of this sentence. Okay, so in the next lecture, in a couple days, I will introduce more rigorously these semantic notions of validity and contradiction, tautology, etc., and then we'll then be able to see more fully how to apply this method of constructing truth tables to determine whether sentences or collections of sentences have these semantic properties. But in this lecture, hopefully I've shown you how to begin constructing truth tables, and this is an important skill which you should develop in the next couple of weeks.